in this episode, I have a special guest for you. It's the company Cummins. The industry is vehicle manufacturing from Indiana, a global power solution leader for diesel engineers, electrified powertrains and power generation. Approximately, they have 70,000 employees, so big knowledge and, of course, active projects in industrial IoT. So they have hundreds of OEMs and the vehicles are extremely configurable. So that's why they need kind of a modular software architecture. And yeah, we want to learn how did they do it? So what obstacles did they encounter? And maybe what you should also have in mind while implementing similar projects on your own. I've invited Carlton Bale. He's director of software at Cummins. And then we have Martin Brown. He's software architect also at Cummins. And their chosen IoT partner is with us on board, the tech enabler Portainer.io, where they are using the technology from, representing today by Neil Cresswell. He's the CEO and co-founder based in Auckland, New Zealand. Yeah, and as always, you could find the implementation info on IoTUseCase.com. And with that, I will say, let's go start with this episode. Hi in the round and hello and nice to have you today, Neil, Carlton and Martin. So Neil, how are you today? How's your week going?
Very good, very good. Spent the week so far in Germany, which I love. So yeah, very good.
That's nice. So by the way, are you normally in New Zealand then, or where are you based?
Honestly, for the last 4 years, I have spent most of my time in seat 14A and hotels around the world. So I travel about 270 days of the year. But as of this year, I'm now actually resident in Phoenix in Arizona.
I see. Okay, nice. And then Carlton, Martin, how's your week going? So Carlton, maybe to start with you, how was your week and where are you based at the moment?
Yeah, so it's been a great week talking to some of our OEM partners, and we're going to continue to work on what we're going to talk about here today. And I am based in Carmel, Indiana in the U.S. today.
Cool. And Martin, are you on the same place or are you somewhere else?
I'm close enough. I'm in Columbus, Indiana, about an hour to an hour and a half away from Carlton.
I see. Okay. So, and where's your corporate headquarters then? It's
in Columbus, Indiana.
Columbus. Okay. So yeah, greetings to everybody who's listening up now. And of course, everybody else joining us today. Yeah, maybe we could start with a brief introduction of you all around today. So Neil, I introduced you already. So you're CEO and co-founder of Portainer. You have more than 25 years of experience in IT, cloud consulting, and you built Portainer to make container management simple and accessible. And maybe to start with a question from your side. So how long do you know Carlton and Martin in this project, and how important is this project also for Portainer?
So Martin and I go right back to the very, very start of the project. I can remember the very, very first Zoom call where there was about 20 people on the call interrogating us about the product and how it works. Carlton, I think we met for the first time last year. And how important is Cummins to Portainer? Incredibly. You know, Portainer, as it morphed from a data center tool to a industrial tool to an IoT tool, scale kind of amplifies quite dramatically as you go. You know, having hundreds or thousands of devices in a data center is a big number. Having thousands of devices in an IoT fleet is a very small deployment. You're talking hundreds of thousands or millions of devices in an IoT project. So using Cummins as our co-design partner to make Portainer reliable and scalable at that kind of scale for IoT has been incredibly useful for us.
Okay, that's nice. And I'm looking forward to learn more about that in a second. So how you're doing that and to learn more about also Portainer here. Maybe to close the round, Martin, maybe to continue with you. So you're the lead IoT software architect here. Your background is, I guess, in edge computing, embedded systems, containerization, and you've been quite in the center of designing your Cummins also edge software platform. So would you say you're kind of the lead architect of this solution, kind of the techie in our conversation today, or how could I take your role?
Yeah, I'm the lead architect for the application side of the software. So we kind of segregate it into application side and then the middleware and the OS. So my manager has been leading the middleware and OS, and he's overall the leader of our solution. I have been leading the application software aspect for the IoT project, yes.
Perfect. And then Carlton, you are leading the future generation of the software-defined vehicle development here. So your focus is to make sure that the complex and highly configurable engines can be managed through your software. So would you say you're more the visionary here to driving the future of these software-defined vehicles at Cummins? Or how would you see your role in this project?
Yeah, that's a great description. And I feel lucky to have the position to come up with these crazy ideas of running containers on edge devices. We're talking 2019.
Yeah.
And then to be able to work with Martin and others to make it a reality. So I think perhaps the vision coming up with where things need to go is the easy part. Working through the adoption of that once it's identified, that's the challenge.
All right. So what should we know about the company? I mean, I did a very short introduction, the intro about Cummins. So could you tell us a bit more about, what we should know about this project and your company behind?
Sure. So the background of our company, and mostly this project, is focused on commercial vehicles. And while we have a large number of OEMs, 20 plus large OEMs, we tend to focus on our biggest four. And the issue, though, was for us to offer connectivity telematics features, there was nothing available from the equipment manufacturers back in 2012 when we first launched this initiative. So what we had to do was partner with aftermarket telematics providers, and we had to write our software for their specific hardware and software implementation. And that wasn't so bad when we had our first two partners. But over the next several years, this scaled to 35 partners.
Okay, wow.
So we were maintaining 35 different versions of the same edge and connectivity functionality. So when we launched this project in 2019, the idea was we need to simplify this dramatically. We want write once, run anywhere. And the best approach to separate the application layer from the operating system layer was OCI containers. So we made kind of a brave approach for us at the time to go away from our legacy embedded architecture with our own telematics device and switch over to a more modular architecture where the application was in an OCI container, and then we defined the application interfaces into that. And what we were able to do was successfully demonstrate that it is viable to run software in this manner and to start to get industry adoption outside of our company of the same approach.
Okay, just to clarify the keyword, so when you talk about OCI, you mean the Open Container Initiative, or?
That's right. So it is the Open Container Initiative, which is a group of many companies who come together to define the standards of how software can be containerized and run in an abstracted environment. And this is very common in the cloud. Where it wasn't so common was in edge applications and especially in automotive, which is much slower to adopt new technologies.
Okay. And do you have some examples of your OEMs here?
Sure. So PACCAR DAF is one of our largest OEMs. I'm sure everyone is familiar with Daimler Trucks, who has a presence also both in Europe and the US. And the Traton Group, which is Scania and International Trucks.
I see. Okay. So, and then you're mentioning it's all about the connectivity and the telematics features you're doing here, and it's then about maintaining them. So you have a lot of maintenance efforts here.
We have in the past, that's correct, where we had 35 different versions of software. Where we are going forward is that we provide our partner with an OCI container. They deploy it to their connectivity device. It solves a lot of problems for everyone because we no longer have to have multiple versions of our software, and our OEM partners no longer have to work with so many different suppliers who all try to provide different types of software packages.
I see. Okay. And that's also where the business case is about, I guess. So we'll talk about this in a second. Can you take us back maybe to the beginning of the project? So what is the project about, and how did this partnership between Cummins and Portainer actually come about?
Yeah, so like Carlton said, Carlton had the vision to use OCI container technology on these devices. I was fortunate to be selected to lead this effort and the architecture for it. So about 5 years ago, when we knew we wanted to use this software and this technology, it seemed like all of the pieces were there, and the standardized container packaging and the standardized format, the standardized cloud container registry, the standardized local container orchestration and execution. We found a major gap in that we did not have a way to remotely orchestrate the containers down from the devices, because these devices, once they're manufactured, we don't want to touch them again physically. I did a POC and a test drive of Portainer. I was showing the team how Portainer's solution was checking off almost every single box, right? And then to put the icing on the cake, when we reached out to some of the other suppliers, they were pretty hands-off, not very engaged, and they were more like, hey, this is the product. You can test drive it. There's an open source version. You can test drive it. But if you want to use it, that's when you come and talk to us. But Neil and his team, they were engaged from the beginning, and it felt like they were with us and they were our team members, and they were working through solution with us even before we even had an actual agreement in place. So that made them the obvious choice.
Cool.
But also back at the beginning, I think both sides, Cummins and Portainer, kind of didn't know what we didn't know. You know, both sides knew that we wanted to run application containers to run the software for telematics and everything else. But how? How do we do this? Because like, as Martin said, once the device is out in the field, to physically touch it again is a product recall. You know, you're actually recalling something to a dealer, and it's like, you don't want to do that. That's expensive. So how do how do we ensure that you never need to touch a machine before? How do you ensure that an application update never fails? It has to be atomic. And it was like, hey, this is quite a cool little challenge. Let's get deep with these guys and actually build the future with them.
I see. So, and that's where you with Portainer IO are going inside with the technology to do the updates over the air. I put the buzzword here and put it in like a standardized way to do it more fast, secure, and also scalable for these OEMs out there.
Yeah, I mean, there was a long list of ideals, but there was also a long list of constraints.
Yeah.
And so it's pretty easy to say, okay, look, you want to be able to do over-the-air updates, and they have to be atomic, but there's no other real constraints.
Yeah.
So there's no bandwidth issues, there's no data transfer issues, there's no power supply issues, there's none of these issues. But most of those things weren't true in this case. We had a big long list of constraints as well. So, challenges coming from both sides. How do you have a very feature-rich solution, and how do you operate that feature-rich solution in a highly constrained environment? Security, network constraints, device constraints.
All right. So before we dive in how you did that and maybe also share some best practices here. So Carlton, can you summarize kind of the main goals where you started this project and you say, hey, that's important for us. That is the main goal for this project. And when that happens, we will be successful here.
So our number one objective was to demonstrate the viability of this approach to running software. And to do that, we had to take something to production to show that it's possible. The secondary issue was we had to launch on time. We had a program timeline. So there was a lot of concerns inside the company as far as, okay, we had our legacy telematics device, which had a completely proprietary stack and a proprietary application development platform based in Java. What we said is, we're going to replace this entire stack, including the operating system on up. We're going to build it ourselves, and we're going to work with partners like Portainer to do this. And we're going to hit the program timelines. And there was a lot of skepticism that it would be possible to do that much work. We had to demonstrate the viability of this, but also we had to rely on our partners to deliver solutions. Some of the interesting work that came out of that is how do we leverage our container orchestration through Portainer to orchestrate other parts of software in the vehicle, meaning how would we update the Linux operating system on our edge device, and how would we update the software in our ECUs. And Martin and team came up with a very interesting and novel solution to use one orchestrator, which was designed to orchestrate containers, to be able to update the rest of the vehicle as well.
And the whole vision behind that, I mean, you're mentioning your OEMs, of course, to simplify this maintaining process. And that's the vision also for your customers and stakeholders in this whole supply chain.
That's right. So we serve two sets of customers. One is our OEM customers. So we sell our powertrain to the OEMs. But ultimately, these OEMs deliver the completed vehicle to the fleet. And we deliver solutions to them as well that give them insights on how their vehicle's performing and what failures may be occurring. So what we ultimately want to achieve is no matter how a customer experiences our powertrain through whatever OEM, they get the same features and the same experiences regardless. And to do that, we have to be able to deploy our software across a large variety of platforms. And we have to be able to update that software to the latest versions to make sure we have all the features that a customer is expecting.
All right. So Martin, how would you explain the technical use cases you're solving here when you're implementing this project?
Yeah, so we start off with just being able to do software containerization and running that on the Linux embedded device that's mounted on the engine. And that Linux embedded device, it talks to our engine control unit. Some of the use cases are how do we remotely manage the deployment of the software updates to the Linux devices out in the field? But not only that, but how do we update the engine control unit, our own engine control unit that is also running alongside that embedded Linux device, because that engine control unit, it does not have connectivity in and of itself. It can't by itself reach out to the internet and pull its own software update. So it has to go through our embedded Linux device to do that. So that was the two major use cases, is updating the telematics software that's running on the embedded Linux device that performs all of the business logic and high-level more features that supplementary to the engine. And then how do we update the software running on the engine control unit via that Linux embedded device? And out of that, we ended up publishing a paper on IP.com. That paper is titled Updating Embedded Linux OS Using OCI Container Technology.
Okay, that's cool. By the way, is this paper official? So can I link it in the show notes, or is it an internal document?
Yes, it's official, and it's on IP.com, yes.
I see. Okay, then I will put you guys that in the show notes, so please have a look. And Neil, by the way, when you hear these kind of use cases, I mean, you're working with a lot of different customers. Are these like typical use cases you're solving with Portainer technology and your product?
So when we first started out, it was completely bespoke and unique to Cummins. They were definitely taking a market leadership position here. Now it's becoming more mainstream, that now we're seeing, companies wanting to do similar things. But, back then when we first started, no, they were definitely taking the lead.
All right, that's cool. I mean, in the end, it's also an investment in technology here. So Carlton, can you explain a bit the business case behind? I'm not sure if you have something like a return on investment calculation on that, but maybe we could share some business challenges and the business case behind.
Sure. So one of the biggest differences with commercial vehicles is they are very cost-driven. The fleets operate on small margins, and they look for every efficiency they can get. So what that means is most of our decisions are driven by cost reduction. So either we have this edge software that can help improve fuel economy, or we help improve uptime so that the vehicle stays in operation longer. But both of those reduce the operating costs for the fleet. What we had to approach this as was a cost reduction opportunity. And I think it's pretty obvious that maintaining 35 different versions of software through different partnerships was not really sustainable. It was also quite expensive. While it was a large investment up front to create this software stack, it was more about the strategy of how do we open source some of these interfaces that we've designed so that they could be adoptable by other platforms. So interestingly, like one of our biggest challenges was the internal decisions and discussions to convince our leadership team that we could make this switch to an open architecture and that we could get adoption. So to give some context, our previous proprietary platform, it had been in production for 2 years and still had not delivered all of the features that it was supposed to have at launch. So there was reason for skepticism. We had a big risk that if we did not hit our production timeline with this new architecture, it would be even worse than our previous experience. But luckily, because of our partnerships with companies like Portainer and just the ability to integrate different open source solutions into this platform, we were able to move a lot faster and to mitigate those risks. And we actually were able to hit the production timelines.
Okay, I see. And Neil, how do you see that? Do you have any more comments on that? Or
all I know were the time deadlines and the impacts they had on our engineering team, because we were obviously iterating the product's capabilities literally just ahead of what Cummins needed as each step was being learnt and iterated. So there'd be a version of the product and right now unblocked certain capability we wanted, but now we've found something else that is quite useful to add, so we add this. So we were constantly iterating the product development throughout and working to quite tight deadlines. It did take, I think, 2 years to go through the idea to actually something ready to go and usable. But 2 years goes like that when you're iterating version on version of software.
Sure. Do you have some best practices here? What technical challenges came across in this project?
For us, we had to go and create a net new version of our agent. Like the Portainer is a server and an agent architecture. So the server is where you perform all of your management, and the agent is what runs on the devices out there to receive instructions. And we had to create a net new version of that agent for this particular type of use case, just to deal with things like bandwidth constraints and network uncertainty. Again, this is in a moving object that's hurtling down a highway. It comes in and out of cell reception or network connectivity all the time. How do we ensure that network reliability doesn't impact product reliability, software deployments, anything else? So that was really interesting for us. And then also some incredibly strict security requirements, as you can imagine, for something that has a human life inside it. So very strict security requirements as well. So those two were quite a technical challenge for us.
Okay, that's pretty interesting. And also a lot of questions coming also from how to scale and make sure that the solution, is scaling. As you were mentioning in the beginning, like you have hundreds or thousands of devices out there and you have to manage all of these.
Scaling is hard. And scaling is hard because you have this thing called concurrency. When you've got 100 devices and you choose a random time slice, because like when we want to send instructions so that we don't create network storms or other things, we can randomize timing and send instructions.
Yeah.
The chance of getting a collision where 2 devices or 3 devices are doing something at the exact same time, when you've got 100 of them, that's pretty low. When you've got 100,000 of them, the chance of getting multiple devices basically occurring at the same time elevates quite dramatically. And then so how do you handle that kind of locking when you've got things like database rights? How do you handle all this kind of concurrency? And that became quite a challenge as Cummins got more and more devices out in the field. Obviously that challenge keeps escalates. So we had to change a number of elements of our internal architecture to support the kind of scale that would support an IoT type deployment of the eventual scale, which has benefited so many of our customers beyond that because the product is now infinitely better in regards to handling that kind of concurrency.
Yeah, right. So from Cummins' side, do you have any practical comments on that? So would you agree with that?
Definitely the scalability of Portainer. We can even see how it affects the device because if Portainer can't scale, then it can't manage our devices. Portainer wants to be atomic and make sure that, when we ask the software to deploy software updates down to our devices, that if there's any issue, that it's not because of Portainer. Mm-hmm. And once Portainer does its job, then now the rest is in our hands where we want our software to be running. We want it to be able to recover from failures automatically and recover from any software update issues automatically. That was a little bit different because in developing software, when you don't have to worry too much about the hardware and you're focusing only on the software, you don't have those types of issues. When the software comes to play and security comes into play and the remote nature of these devices come into play, you want to make sure that at the end of the day, you can still reach the devices and be able to apply a software update. Mm-hmm. Because if you can do that, then any problem that you have is fixable.
I see. Neil or Carlton, one question. So what kind of product were you using from Portainer here? And how does Portainer ensure that the solution works also not just on one asset, but also can be efficiently transparent to, for example, thousands of vehicles and different OEMs? So how does it work and what was the product behind?
Yeah, Portainer has 2 primary products. We have our open source product and we have our commercial product, right? And the open source product is really designed for experimentation. It's community supported. It's fundamentally built by us, developed by us, supported by us, but it's really for the community. It's not official. Then we have our commercial product, and the commercial product has significantly higher levels of quality assurance and testing and security compliance and all the things that you need to do to manage proper enterprise software. Yeah. And so that's known as Portainer Business, and the other one's Portainer Community. So Portainer Business is the server element, and then we also have the agents, which are micro pieces of software that run out on the devices in the field, in this case, the powertrains, that actually facilitate the secure communications between the Portainer management server and the devices in the field. They're the ones that are ultimately responsible to ensure the software is deployed and running on the device, but they receive their instructions from the Portainer server and make sure that the Portainer server is always kept up to date with running state and health and all that kind of information.
Mm-hmm. Cool. So when you talk about the community, can you give us some, I don't know if you have KPIs, how big is this community and how many people are using that, just to have a number in mind?
Oh my goodness, that's getting harder and harder to answer. We have some analytics in the product, almost everybody turns off those analytics. So the people who have it turned on, we know there's about 1.4 million users of Portainer Community Edition every single month. Log in and touch it.
Okay, wow, that's a lot, yeah.
And when I last checked, there were about 3.4 billion downloads of that community software over its life. So it's big. Most people turn off analytics these days, so we're very blind. In the paid version, we don't have any analytics in that version. Customers are paying for it, so they have their privacy and their secure networks.
I see. Can you go into some details on that? So why did you choose Portainer and what are the results for you right now?
Yeah, so maybe I can talk about why Portainer, and maybe Carlton, you can talk about the results. Choosing Portainer was about the technology and the people there. The technology, it did exactly what we were looking for. Neil mentioned that there was some gaps, but on a high level, we found that the software was like, as soon as we tested, we were like, yeah, this is what we need. And it was kind of hard for us to really know what we needed until we test drove those tools, because we didn't really know what was possible as well. And we didn't want to spend time designing all of that ourselves. But once we test drove several of the solutions that claimed to be solutions for remotely managing OCI containers on edge devices, that was the specific tool we were looking for. And it was obvious once we test drove the tool, how we could narrow it down to two options. And then talking to Neil and his team at Portainer really was the icing on the cake.
And I think as far as what we're seeing as the results of this, it's definitely a lot more convincing when you're talking to partners to say, look what we have in production, instead of look at what we've come up with on a PowerPoint slide. We'll promise it'll work. So having a successful production launch and achieving the scale that we promised, and also getting the reusability of the software that we were seeking, has really shown how this open solution is viable. And we're starting to see substantial adoption of OCI containers across our industry as far as a way to deploy software across ever-changing hardware platforms. And we've also leveraged this as a member of the Eclipse Software-Defined Vehicle Working Group. We're contributing some aspects of what we've developed, like interfaces and APIs and transports, into open source so that it can be adopted as a part of a larger ecosystem that could be even outside of commercial vehicles.
Yeah. And you already mentioned like this ecosystem. So you're building up on partnerships like with Portainer, but also with others. And then is it also part of the strategy to work more closely with your OEMs and other partners together? Is that also part of the strategy here?
Yes, it is. So we have, I would say, two parallel approaches that we're taking. One is working with peer companies such as Bosch and ETOS and Electrobit and Allison Transmission to co-develop this capability through open source collaboration and demonstrate its viability as it continues to mature. And some of our OEM partners are starting to join this open collaboration initiative as well. Cool. Separately, we work privately with our OEM customers on specific implementations of perhaps advising them as they adopt this new technology, what we went through and things that may help them, but also just through the adoption of them being able to run our OCI Docker type containers on their devices.
And that brings me maybe to the last question for this session today. So when we're looking into the next, maybe 4 to 5 years, what would you say how the future is looking like with this project?
So obviously we have implementation plans with our OEM partners, and those will continue to progress as new products are introduced. But what I can give more detail on is the collaboration we're doing through, as I mentioned, the Eclipse Software-Defined Vehicle Group and Covisa, the Connected Vehicle Alliance. What we're seeing is projects like uProtocol and S-Core that develop the capabilities for applications to communicate with each other across all the different domains that exist in a vehicle. And we are contributing to this. We are adopting some of these technologies to test and eventually take to production. And we really think, partnering on this infrastructure layer of IoT, that we can develop this common framework that's not really differentiatable between any of our different partners. And what allows us to do is focus on the applications that run on top of that infrastructure, which is where all the customer value is delivered. So what I really see in the future is transitioning from focusing on infrastructure to focus on applications and customer value.
Okay, that's great. And by the way, when you're listening up now, I will put all the links in the show notes, what you're mentioning on these initiatives and working groups and some more informations. So please feel free to look up into the show notes, and then you will get more details on that. And if that's fine for you, I will also, Carlton, Martin, and Neil, put your LinkedIn profiles in the show notes so anybody can also connect with you through LinkedIn. I hope that's fine for you.
That would be fantastic.
Yep.
Absolutely.
All right, cool. So Neil, what can we expect from you from Portainer.io? What are you heading up the next 5 years?
Oh my goodness, we just never stop developing, let's be honest. I don't think software projects are ever done. There's always something cool and new and exciting to add. Yeah, scale is still something that we want to work on. Right now, we're very comfortable with the scale, being able to handle the scale that Cummins need, but obviously we want to do to 10 times that. So being able to figure out an architecture that works reliably and securely when you're talking into the millions of devices. So how do you do that? We looking at the container runtimes that are used at the edge. Historically, it was Docker at the edge. More recently, there's Podman. But even more so, there's now Kubernetes appearing at the edge. And so as things morph and change in the ecosystem, what does it actually look like in reality? Products like Kubernetes was designed for the data center. It's not designed to run on very, very small devices. How do we do that in a way that's ultra reliable? And so we've already got a project called kubesolo.io that is a really first iteration that says, well, actually, let's bring Kubernetes to very, very small devices in a way that is somewhat constrained, but still Kubernetes. We're also looking at ways of bringing the Portainer UI, so what operators use, simplifying that down to really just focus on the needs of the ultimate user. And in Cummins' case, it's the internal business users who just want to deploy software and make sure it works. So we still expose far too much mechanics. It's a little too verbose. So creating a version of that that's more fine-tuned for the internal user as well.
All right, that sounds amazing. So maybe we could, plan another episode in a year or something to have an update on that. So a lot of developments and a lot of new things coming up in the future. And with that, I would give the last word to you from my side. Thanks for being here today.
If you think back to the start of this project, the foresight and vision to say we're going to take a technology that is still quite new in the data center and put it at the edge, put it in a vehicle. From a company level, for Cummins to even consider that idea is amazing. And then for the individuals involved, it's their own personal careers saying, we are recommending this technology. The actual personal trust and faith and insight into what the future holds is spectacular. So hats off to Cummins. And that's why from a Portainer side, it's like, you guys have got my attention here, and anything we can do as a company to support you, you've got it, because that was spectacular.
Portainer took the leap of faith with us, and they worked with us and helped us to develop a solution. So we're looking forward to continuing with Portainer and you and your team, Neil.
All good. Thank you for the opportunity, guys.
Thank you.
And have a great rest of the week. Bye-bye.